Welcome back to our video on building and securing serverless apps using Amplify. This is part 3 in a 3-part series where we're exploring AWS serverless capabilities and sharing our experiences using the Amplify tooling. I'm Bobby Pantel, and I'll be joined by my colleague Sudhindra Shetty. We currently have a CI/CD pipeline, a hosted front-end app, authentication, and a DynamoDB table. Our roles are prepared, but no back-end services are available to use yet. It's just a simple front end. So we'll finish up the series by building the back-end services that will give us a full end-to-end serverless app. Now, just a little bit about this video series. We're on the third part of the series. The first two involved hosting the front-end app and then adding back-end authentication and storage. And now we're going to add the API and functions. We're using a test app called for campaign management. It's an Angular app. And our expectation is that you have your own front-end app ready, but you can also follow along. We have the code available at GitHub, and here's the URL. Here's a quick view of our target architecture. You can see at the top, there are 5 aspects that we're going to be focusing on with AWS Amplify: hosting, the API, authentication, functions, and storage. And on this particular video, we're going to be focusing on the API gateway, functions, which are Lambda, and storage, which is DynamoDB. So now we'll jump into the code, and our goal for this video is to create the APIs and Lambda functions for the CRUD operations on our DynamoDB table. Our backend code will be written in Node.js within the Lambda functions.
Get into the code. In the previous video, we saw that we deploy the authentication and the storage resources in the backend, and you can see that under the backend environment that it was deployed successfully. The front end was hosted in our first video, and you can see that it's all working fine. So in this video, we're going to focus on implementing the APIs to basically integrate our front-end code to make those API requests to store the data in our backend. So let's get into the code and start doing that. So to first start creating the APIs using Amplify, the command is amplify add API. In this case, we're gonna create an API for this app, and we're gonna name it as campaign API. And it's gonna ask us like several questions when you go through that process. We're gonna stick to a REST API, so I'm gonna select that option. So I'm going to give a friendly name called campaign API because this is what we are going to use in our code, and the path that is going to use to make those HTTP requests is going to be campaigns. Just make sure you put the a front slash when you're typing that name. So each API is gonna go through a Lambda function to basically execute those methods. So I'm going to create a new Lambda function here, and I'm going to go with a default name in this case. The runtime that I'm going to use here is Node.js because it kind of provides us a template to do the CRUD operations later. And you can see here the CRUD function for DynamoDB. So this is the template that is going to help us create the code for performing the CRUD operations. And you can modify them later with more logic. The table that is going to use to basically store the data while making this request, we're going to use the existing table that we created in our second video, which is a DynamoDB table. So I'm going to use that, and that's the campaign app. Do you want to configure any advanced settings? I don't have anything right in this case, so I'm just going to stick with the available default ones. So I'm going to say no. Do you want to edit the local Lambda function? No. Restrict the API access? Yes. We do want to restrict our API access so that we don't give anybody in the world, like permissions, if they are not authenticated to invoke this API. So we're gonna push the API access using that. And it's gonna give us a couple of options here, the authenticated users and guest users. In our case, we are only gonna stick to the authenticated users. But in case if you have any guest users who want to navigate in your application, you can create like certain permissions for them. So I'm gonna pick the access that you want to give to the authenticated users. I'm going to select all, create, read, update, and delete. This is which is basically your CRUD operation.
Oh, Sudindra?
Yeah.
Just a quick clarification. I think with the authenticated users, when you're restricting API access, depending on the permissions, if you use guests, that'll map to that unauth role that was created. We talked about, I think, a couple videos ago. So there's an auth role and an unauth role that map to whether they're authenticated or whether they're guests.
That's right. Yeah. So each so based on the role that you're gonna assign to users. So if you have an auth role, it will have like certain permissions. So in this case, we are giving access to our API to authenticated users only. So it's going to go through the auth role, which is an IAM role. And similarly for the guest users, it's going to go to the unauth role, and it will have a certain policy defined for that particular role. So based on how you log in into your application and the role that you have assigned to those users, it's gonna map accordingly. So yeah, I think that's right. So you want to add another path in this case? I don't have to because I don't have anything. Say no. And right now, it looks like the API is all ready to be provisioned the backend. So I'm going to push this using the Amplify command, which is Amplify push. So it's gonna ask me, do you want to still like continue by showing me the status in my local? And you can see here now under the backend, the API folders have been created. We basically creates a CloudFormation template uh, that's needed to deploy the API. So it looks like, yeah, so it's going to create your API and then your function. And here you can see the functions as well, right? So the API is going to be created and the function that's gonna help serve the API. So both are gonna be provisioned here. So I'm gonna continue that, and it's gonna take some time to deploy or provision these resources in the cloud. Let's give it some time for it to do that. And in the meanwhile, I think I can show you the CloudFormation template. Let's do that. And you can see here the update is in progress. And if you go into each tag, you can see more details of the resources that have been creating all the Lambda execution policy, Lambda functions. So there is a invoke policy and execution policy that will be created as part of the Lambda. So invoke policy is basically going to talk about which API can actually invoke this Lambda function, and it is going to be very specific to the API that we created. And the execution policy is basically that defines what permissions does the Lambda function have to execute. So in this case, it will be a DynamoDB a table, so it can do the put, delete, update, all the CRUD operations. So that's the policy that is creating behind the scenes. You can see the API gateway stack, auth stack getting created. So that's basically going to create your API gateway policy, so which IAM roles can invoke these APIs. So looks like it's all created, and the API endpoint has been created as well. So let's go to our API gateway. looks like the campaign API that we created has been successfully provisioned. You can see here the different stages which we have. We have a dev stage at this point, and these are all the methods that it can support. And you can see here there's a proxy along with that path. So the advantage of this is you can have your path as campaigns, and you can have any other additional paths that you want to create for different methods. So with the proxy as your path, you can create those different flavors of your path for each method. So that's the beauty of that. And you can see here the auth is using is AWS IAM, and this is the IAM role that is going to use to basically give permissions to execute this API and invoke this Lambda function. So let's go to the IAM role and see that what permissions that it has. So this is the auth role that we were talking about a while back. And you can see here, this is the policy that it created for our auth role, and this is basically tied to our API gateway. And so go into the permissions for that, and you can see here all the methods that it can invoke, right? So that's tied to the API gateway. Similarly, when you go to Lambdas, the Lambda that we created was campaign app dev, and once you go into the permissions for this, you can see here that it has a execution role, and once you click that, this is a Lambda execution policy. And if you go into the details of this policy, you can see here it does have the permissions to create a logs in the create and update logs in our CloudWatch, but it also gave permissions to basically do the cloud operations on our DynamoDB table, and it's very specific to this resource, which is a DynamoDB table resource. So that's the execution policy for that Lambda, and there's an invoke policy here. You can see here only the API gateway can invoke this Lambda. So it's very specific, like who can invoke this Lambda function. So that's pretty much it on the permission side. Looks like our APIs and the functions were created behind the scenes. So let's go into our front end code and start integrating it so that we can perform our CRUD operations to create, update, and delete the campaigns, right? So before we do that, previously we were performing everything from the front end without getting anything from the back end. So we had some code that were I think that was commented out because this code is basically going to help us integrate with that backend. So let me revert that back to basically help us perform that. I'm going to toggle that, and I'm going to comment this code because this is what we were using previously, right? So this is going to be help. So this code is going to help us, save and update our campaigns. It's going to create and update our campaigns, and you can see here this is the delete campaign that is going to be hooked up with our backend. What else? So let's go to our HTML to support that. In HTML, I think we'll have to revert this save campaign one with save campaign, which is what we uncommented before. And in this service, as you can see here, we were getting it from a JSON file before. So let me comment this out. And uncomment this code. This is basically going to be using the API, the Amplify API package to get the records from our backend. And this is a path that we created before. It's called campaigns, and this is the API name of the API that we created. So this is the API name, and this is the path that is gonna use to do the CRUD operations. Looks like everything else is fine. Let's go to the app.js code. So the API that was created is gonna be going to a Lambda function. So, and we have used a Node.js as the runtime code, and it kind of creates all the code for you to manage the CRUD operations. And this is a default code. You can modify it and add more logic based on the requirements. So as you can see here, the table that is going to use to do the CRUD operation, which is a campaign app, and this is the path, and this is the partition key and the sort key that we created in our second video. And here, this is the get that we are invoking from our service method, right? So in our case, we want to get all the items from the table, and the code that is generated is basically doing a query. The query always requires a partition key because you're gonna filter your query to a specific partition key. So in this case, I want to get all the items that's stored in our table. So I need to do a scan of my table, and it's going to also look for this hash key path, which is basically your partition key name. So I don't need that. In this case, I'm going to remove the hash key path. So the path that is going to look for is your campaigns, and it's going to do a get on this method. So let me save these changes and push it to our backend. So now that the function was updated, just yeah, go ahead, Bobby.
No, that's fine. There's the back end. There's an open change on, that's the client side, the campaign service.
Okay, yeah. So I'm just gonna push the.
You're just pushing the back end. Okay.
Yeah, it's the back end. So I'll perform that. And once that's done, we should be good to perform the client operations. One more thing I wanted to bring to your notice was we added toast. Okay, let me just continue here so that the updates are function. I have added like toast messages on the UI. So whenever you do a CRUD operations, it will give you an update whether it was created, updated, or deleted. So I've used the PrimeNG toast component for that, and I've imported that in our app module. So if you run across that issue, just make sure that you import that in your app module before you start using it. I want to show you the methods that it got created in the app.js. So I think I forgot to mention that. So this is the get method that we are going to use to get all the items. Similarly, there is a different flavor. So this is the proxy that I was talking about some time ago. So for each path, you can have a different proxy associated with that. And then you have the put, you have the post. They both are kind of similar. So whenever you want to make updates to your items in the table, you either do a put or a post. Delete is basically trying to remove the objects from the table. That's pretty much it. So it looks like the function was updated, and let's get on to our code. So it looks like our app is all running. So let's go to the client side, and then refresh. So you can see here, there is nothing stored in our table at this point, right? So let's add a new campaign here. Let me add a new campaign. And we're going to save it. So this should basically be saving in our DynamoDB table. It's going to be invoking our API, and it's going to be doing a post and saving the data in our backend. Let's do that. So it looks like the campaign was created successfully, and you can verify that in our DynamoDB table. This is the table that we created, campaign app dev, and you can see here there's one item that was created, and this is what we created on our screen right now.
So here are some key takeaways for this video. I want to talk a little bit more about the unauth and auth roles. Those correspond to the guest or authenticated users within Cognito. So when you walk through the Amplify CLI auth process, you'll be asked if you want to generate guest or authenticated users. And if you choose guests, then those guests will be guest accounts will be mapped to the unauth role. So be sure you understand what resources the unauth role, IAM role, has access to. For API gateway security, we're mapping Cognito groups to IAM roles within the API gateway. So those roles, when someone logs in with their Cognito account, they'll have groups associated with them, and those groups will be mapped to IAM roles. So those roles include resource policies to determine authorization levels, what ARNs, resources, AWS resources they have access to. So just understand that there's a mapping again in API, the API gateway, between the Cognito groups and IAM roles. Don't forget about content security, specifically CORS, cross-origin resource sharing. We enforce that in our Lambdas, and it's configured in our response headers. So we only allow certain origins to access our backend. And so it's something you don't want to overlook. So we do it in the Lambdas in the backend for CORS. There's also content security policy to prevent cross-site scripting and other attacks. You can define content security policies in the custom headers section in Amplify. And there's more information here for content security policy if you want to do a little bit more research, but just make sure you understand what type of content you're allowing on both the front end and the back end. And finally, to just encourage you to get familiar with the CRUD template generated by the Lambda code. It's a good start, but you probably need to tweak your code for your use cases. You can use different languages, Java, Go, Python, .NET. We're using Node.js and specifically the Express.js middleware because it works well with REST APIs. But the good thing about Amplify is it generates this code for you, and then you can tweak it from there. And that's it with the series. Just remember, Amplify functionality is constantly changing. We use version 7.5.4, and as we were going to production with this video, we realized there were a lot of changes in the latest version of the Amplify CLI. So it changed the build file structure and the way that you override the templates that are generated by Amplify. You override them using the Cloud Development Kit, the CDK. So it provides much more granular ability to make more specific changes using TypeScript or other programming language. So just a different way of managing files. So just be aware of that if you use our code at 7.5.4, but that structure has changed. And just mentioning that Amplify is just a great head start for serverless app development. It generates code for you, but you can always override and tailor it to your needs. So just provides you a great start. And finally, Amplify Studio is visual development, which we haven't gone over here, but they've really expanded, AWS has really expanded that functionality to use pre-built UI components, a visual backend builder, and just importing design from tools like Figma into importing design prototypes and generating React code. So just check that out too if you want to look at more visual tools rather than the Amplify CLI. So thanks for joining.